into this. Here's what we're looking on, number 17 on that sheet. We're going to do partial fraction decomposition. You're going to watch this first one, and what's going to happen is you're going to kind of hold on and say, this is complicated, there's a lot of steps in here, but you're just going to absorb. When we get to the second one and you want to pick apart some details, that'd be perfect. But sometimes you just got to sit back and absorb, knowing that maybe the next time through you're going to get it. So check this out. So when you do partial fraction decomposition, here's what our goal is. We take this fraction, this negative x plus 16 over x squared plus 3x minus 10, and we bust it up, because it's fun to bust things up sometimes. So I'm going to bust it up like this and like this into two fractions that are simpler in some ways than the original rational function. So that's the idea. The thing we have to find, the denominators of these, they're kind of fun to find. What we'll do is we'll always factor the denominator. It'll always be factorable. In this particular case, it is, by the way, there should be an x in there. It's going to be what? X plus 5, x minus 2. X plus 5, x minus 2. Old-fashioned factoring of quadratic stuff. These will be nice. Okay, and on top it's still negative x plus 16. Now, those factors in the decomposed form, just another way to rewrite this thing, those factors end up being our denominators. So x plus 5 and x minus 2. Okay, so that's all kind of swell. All right. Now, what goes on top, we don't know yet, but we're going to find out. We're going to call them A and B. So the work that I do right now is all about finding A and B that go on top of there, so I can rewrite this in what's called decomposed form. Okay, so let the fun begin. The next step is really crucial. If you can imagine that when I have two fractions like I have over here on the side, these two fractions need to be added together, and we're going to use our super cool trick that you remember from back in the trig days, where you multiply each opposite denominator by each opposite numerator, kind of. Let me get back to that here. So if I take this negative x minus 2 thing right here, I multiply it by a, and then I take x minus 5 times b, and then over the product of the denominators, that's what I'm going to take on. It's that shortcut. So just kind of hold on and make sure you can remember that. So that's a times x minus 2 plus b times x plus 5. Okay, cool. Just use paper, right? No big deal. No big deal. And over the product of the denominators, x plus 5. X minus 2. Okay, and then on the left-hand side, still negative x plus 16 over x plus 5 over x minus 2. Okay. So that's the start of it. We factored the denominator. That became the denominators of the new fractions. We added the two fractions with the cool common denominator trick. Now that we know that these both are equal, they're definitely equal expressions. The denominators are already the same, so what we're going to do is just set the numerators equal to each other. Okay. So setting the numerators equal to each other, once you know the denominators match, we don't really have to worry about the denominators anymore. My goal is to find out what A and B are, so I'm just going to set the numerators equal. So I'm going to make some room. Now, we are going to skip 18, so you're welcome to cross that out. You're going to do 19 on your own, but I'm going to do an additional problem. So 19 is probably going to end up on some other piece of paper, just warning you. That also tells you have lots of room to finish this off. Okay, so what you have is negative x plus 16, the numerator on the left, is now equal to the numerator on the right. And what did we end up with? It was just a times x minus 2 plus b times x plus 5. Okay, those are our numerators. And you guys are writing notes down because you're superstars. You're thinking college-like, and when you're taking notes, you just write what you need. I'm saying things that I'm not writing down. You write them down. That's something you're getting better at, and that's a good skill. So when you add those fractions, set the numerators equal. Now we're going to do what kind of comes naturally. I have numbers outside parentheses. You distribute them. Okay, so we'll distribute those. We're going to find out what A and B are, but first let's just do the stuff that kind of comes naturally. Okay, bx plus 5b. And then this next piece is really important. So you distribute. Now we combine like terms. So it's like old school algebra. But let me point out what the like terms are. They're a little bit harder to find. We're going to do color coding. Okay, so here goes. The x's, I mean like terms as in, you know, ax and bx. Those have the same power of x. So I'm going to add ax and bx together. And then another like term would be like these guys here are actually numbers, because a and b are actually just two numbers that I'm trying to find out. So those are like constants. Okay, so we're going to combine those. Let me show you how that looks. When I add the ax plus bx, it's like taking 5x plus 2x. We'd call that 7x. In our brain, we're adding the two numbers in front of the x. So this is, we're going to rewrite this as a plus bx. That's what these guys become. Okay, so a plus bx. Okay, that's the combination of my red stuff right there. And then the combination of my green stuff, which we'll get to in a minute, I'm just going to put those together as like a constant. So I'm going to put plus and then in parentheses here, negative 2a plus 5b. And that's the green stuff. Okay, just kind of rest your eyes on that for a little bit, because that's the process that we've gone through. These are the big to-dos in decomposition. You factor your denominator in the fraction. The denominator factors become the denominators of the decomposed parts. Add the fractions. Set the numerators equal. That's where I'm at right here. And then you combine, distribute, and combine like terms. Then the fun begins. If you look at this, if these truly are equal, and they are, we're saying that the left-hand side is equal to the right-hand side. What you'll notice is that we're saying then, well, if these are really equal, then that a plus b is going to have to end up being negative 1. Whatever a and b I choose, it's going to have to add to negative 1 if this is going to work. Well, there's a whole bunch of numbers that add to negative 1. But that kind of limits it a little bit. Then you also know that, hey, did you know that whatever negative 2a plus 5b happens to whatever a and b are, negative 2a plus 5b is going to have to add to 16. That's a very specific restriction. Those two restrictions together end up being a system of equations that we can solve with all our specific, like any kind of method you want. We got lots of tools. We got a plus b has to be negative 1 according to this equation, and negative 2a plus 5b has to be 16. What? Okay, all right, just look at the two sides. You're thinking the right-hand side, if it's really going to match the left-hand side, a plus b's got to be negative 1. I don't know what they are yet. Negative 2a plus 5b is going to have to be 16, or they're not going to be equal. So let's find out what a and b would have to work out to be in order for this to work. And choose your favorite method. I don't care how you solve the system. You just get to solve it any way you want. Solve the system. Now, I don't know about you, but do you want to do some elimination? You want to do some substitution? Do you have a preference? A little substitution? We can do that. All right, let's do substitution then. If we substitute, I'm thinking that we get a is negative b minus 1. All right. And then I can put that into a in the other equation. You like that? So you get negative 2 times negative b minus 1. Oh my word, Sutton, what have you gotten us into? This is just the most amazing. This is great. This is going to work out.
No, it's not.
Sure, we get, what, 2b? Or is it not 2b? That's the question, I don't know. Yeah? You liking this so far? It's looking good? Can you get there? Can I do 2 steps at once? Can you go 7b and then subtract 2 from both sides? Is 14. b equals 2.
Nope.
Woo! That's fun. That's the deal. We just found out b is in fact equal to 2. Okay. So you ready? I can use that 2 anywhere I want to go get a. I want it to go up here. So let's put it in that one. So a plus 2 is negative 1. That means a must be negative 3. All right. So we got it. So this is what we found out. A is negative 3 with substitution, and b is 2.
You're
Not at all. It was completely sequential. You're the first today. All right, -3 was the A coefficient. Now, on the bottom, remember, it's x plus 5. And then B ended up being +2. Oops. Okay. I'm going to back off so you can kind of peek at this for a second. There's the whole worked out deal. Okay, so you have to think of what the steps were. This is, got some steps. Did you get, you can factor the denominator. That becomes the denominators of the fraction pieces. You add the fractions with the A and B, they're just unknowns. So we did common denominator trick, x minus 2 times A, x plus 5 times B, added them together, multiplied the denominators, set the numerators equal. Distributed, combine like terms. And when they're side by side, you notice they're in the same form. When you combine like terms, they're going to be in the same form. Some number x plus some number. So with some number x plus some number, A plus B is going to have to be -1. So we said A plus B equal to -1. This thing is going to have to be 16, so we set it equal to 16. That's classic system stuff. That's what we've been doing. We've been solving for 2 variables with 2 equations, substitution, elimination, matrices. You choose. They all work. And we get A was -3 and B is 2. This left-hand equation, or fraction, is equal to 2 busted up fractions. That's the decomposition process, breaking it into parts. You might think it's crazy for a lot of reasons, but the reason we do it here at Waukee High School, and some of you are going to end up doing real soon, is that when, for instance, you're doing integrals in Calc 2, we get to this type of integral. That little snaky symbol, you don't need to write this, don't put it on your page. But that little snaky symbol means integral. It's called an antiderivative. We do it for things like finding the area underneath the graph of this. If I graph this and said, hey, how much space is there under the graph? That's how I do it, integrals. Well, the integral on the left and the integral on the right, even though they're doing the same, performing on the same function, the same value, the one on the right is way easier. It's a visual integral. The one on the right is -3 natural log of x plus 5 plus 2 natural log of x minus 2, done. The one on the left, no idea, until you decompose it. So we do it because it's easier for other parts that we take on. Okay, so that's the soak it up, get as best you can out of it. Now, we're going to do another one to prepare you to do 19 all by yourself. So watch out. You ready? Here comes a page. Page below. Let's do it on lined paper because it looks cool. Write this one down. Anywhere. I don't care where. In that magic spot that you put magic stuff. Here's your all example. It goes like this. -2x squared minus 8x plus 45 over x cubed minus 6x squared plus 9x. Okay, so variation on the last one that we did, definitely different. Same process though. So here's how it's going to work out. We're going to end up decomposing it into some fractions. I'm going to do all the simplifying first on the left-hand side. I'm going to factor the denominator. First thing you do is factor the denominator. And you may have forgotten how to factor that kind of denominator. There's a greatest common factor, like they all have an x that can be pulled out. You always do that first. Find what you can factor out. Then you got x squared minus 6x plus 9. Okay, that's one part of the factoring. Look for a greatest common factor. Second, you want to take that quadratic, bust it up. X minus be x minus 3x minus 3. Okay. So do you remember in our last problem we had it factored into 2 linear factors, x plus 5, x minus 2. Those are called linear factors. How many linear factors do I have now? 3. How many denominators do you think I'm going to have? 3. Yeah. Turns out the number of linear factors in my denominator matches the number of fractions this is going to get busted up into. So, factoring is it. All right. Got your factoring? Guys, you can't space out, and you can't say anything except, I can factor, Mr. Seeley.
I can factor.
That's the spirit.
Not.
Okay.
Why'd you put a negative in? Oh, never mind. There's
All right, you got those? So our factors, now you're going to expect them, right? You know it's coming. How many of you are thinking x minus 3, and x minus 3? That's what I'd be thinking. Got to throw a little curveball at you. It's almost right. Okay. We're going to do x minus 3, and x minus 3 squared. And I'll tell you what. There's a rule in decomposition that says, let me get this all written in. I'll let you guys copy here. So I'm just finishing out these. I want all these different layers because there's kind of some steps along the way I'm going to get you all caught up on. You'll be good. Actually, I think this one I'm going to need space on. Hang on. We'll see. I don't know. This one might be determined. Depends on how fast I go.
You're killing me, Smoke.
Okay. Oh, I like that movie.
What movie is it? I don't remember.
The baseball one.
Yeah. What is it called?
Sandlot. Thank you.
Sandlot, yeah.
It's a good one. It's cute. All right, there it is.
Zoom out, please. Thank you.
Look at that bottom piece.
I need to see.
Now, do you guys see what I did on that last step? How I put the x minus 3 squareds together? It's actually an essential step. It's not just a little extra. It is not an extra. Hervé, you got to head out, man, if you're going to be distracted or distracting. You don't have to be around. We can make room.
Whoa.
That goes for all of you. If you can't,
You're out of here.
hang in there or hang out.
Strike 2.
So, x times x minus 3 quantity squared, that is an essential step. And the reason is, it has something to do with why I wrote these denominators the way I did instead of just regular. There is this rule, and I'm going to walk up you guys on the board, and this is, I'm going to make, it's up on the board, but for those who are watching the recording, I'm going to write it up again. This is the x, so on the top right, you'll see over there. You can see it also up on the big screen. Here you go. And so we can get this to show up here. Here it is. If you have a denominator with a linear factor, like we're seeing, linear means like this x minus 3, if I were to graph it, would be a single line. That's what I'm talking about. But if it's like to the 4th power and on top you got, something, doesn't matter what it is. When you decompose that fraction, you actually have to come up with, it's going to have 4 denominators because that degree 4 has something to do with it because it's x minus 3 times x minus 3 times x minus 3. But the factors are going to be x minus 3 to the first, x minus 3 to the second, x minus 3 to the third, and x minus 3 to the fourth. So the way decomposition works, and it literally will not work without this, if you have a linear factor of degree 2 or higher, you need to have that linear factor as a denominator for every power up to that degree. So it's degree 4, you're going to have x minus 3 to the first, second, third, and fourth. All 4 of them. If you don't, the process we're going through will not work, period. If you want to know why, you can ask me after we do a number of these practice-wise, and then the why will be a whole lot more apparent. The process that we go through just doesn't work if you didn't do that. Okay. The little short deal is, if I made them all x minus 3s, all of these were just x minus 3, x minus 3, x minus 3, and this was a, b, and etc., going off like this, well then I just have a plus b over x minus 3 because they already have a common denominator. That is not the denominator I have over here. That's a problem. Okay, they have to be equivalent. So That's a little bit of a shortcut. Now we're going back. So when you see this factored down to x times x minus 3 squared, this is actually going to help us in our process. So here you go. So x minus 3 squared, make sure you have x minus 3 and x minus 3 squared. The numerators are a, b, and c, so you just need a variable to put up there. We're going to go find them. Now that next line down, I kind of misled you. I don't think we need that extra step. I think you guys are advanced. I think we're just going to go for it because I want to write it in. You can keep your notes with that extra line, but I'm going to squish in here, in fluorescent green, our goal. The end game is, you remember when in the last problem when we got done, we had denominators that were the same? That's always our goal. We want our denominators to be the same. So go back to that last problem that we took on. The denominators were equal, so we set the numerators equal. That's still the case. I still want my denominator to ultimately be this simplified form of my factored denominator. We factored our denominator. You saw that, right? We took out an x, made it x minus 3 times x minus 3. Hey, x minus 3 times x minus 3, that's dumb. We should write x minus 3 squared. That's always going to happen. You're always going to be able to simplify it a little bit. That's the denominator we want. So what I want to do is I need to add these three functions together, and it turns out this is their common denominator. X times x minus 3 squared is the common denominator between those. I can get each of those to have a denominator of x times x minus 3 squared. Guaranteed. Has to happen. Okay, so what would it take for me to multiply on the top here? I'm going to put in, how about this a term? What do I need to multiply it by to become x times x minus 3 squared? How do I get it to that denominator? What's it missing? Would that make it the same? That'll work. That'll get it to be the same. Okay. Can't just put it on the bottom. You got to do the top and bottom. And that's what common denominators are all about. I can multiply this one by x minus 3 squared, top and bottom. Now it has the appropriate denominator. What can I multiply the second one by to get the right denominator? What's it need? It's not squared. Don't have an x. So I got to multiply it by x and x minus 3. So all that has to happen. So this becomes, on top, got to do the same thing, x minus 3. Got to multiply. Okay. How about that next one? What's it need to become x times x minus 3 squared? Looks like it's just an x times x times x. Nice. So when you get to this stage, you know what your denominator is supposed to be. It's supposed to be that x times x minus 3 squared. All you got to do is multiply each denominator by what's missing. Just takes multiplying by a little something else. Just got to figure out what it is. It'll always work out. So as an aside, this isn't something you need to jot down, but the reason, you know when we add fractions like 1/2 plus 1/6 plus 1/12, what denominator would you get to add those together? What would you guys use? 12. Kind of the biggest one. It's the lowest common multiple between those. So you go 12. So did anyone put down 144? Nah, nobody's doing that. That'd be the product of all the denominators. It works, but you're subtle enough. That's the same thing we're seeing up here. I didn't make my denominator x times x minus 3 times x minus 3 squared. I didn't just take the product of the three denominators and put that down here. What x times x minus 3 squared is like a least common multiple. It's something I can make them all into by multiplying by a little something else. So it's pretty easy. Okay. Next. Got a little email that I got to get rid of. Back. Okay, I'm going to take those out. Next line. So you got your stuff on top. I'm just going to rewrite it so it's all clean and pretty-like. There you go. And then bx squared, if I distribute that bx minus 3bx. Yeah. Got some good stuff in there. I'm just going to show you what I got in here. 3bx. And then plus cx. Here it all is. Isn't that pretty? Combine like terms. Do you remember what we did last time? You just distributed everything, kind of all figured out. Well, I'm going to show you a lot of steps just to make sure you don't. Hey, x minus 3 squared is not x squared minus 3 squared, and you better not try that. Don't even be tempted. X squared minus 6x plus 9. And then I think we're good on the other. I'm just going to go ahead and put that extra step in there just to be careful. So the steps, it's all just basic algebra that you know and love. It's factoring. I can factor. Can you split that up? Realize that if one of my denominator factor pairs is x minus 3 squared, we know there's going to be 3 denominators, and one of them has to be x minus 3, the other one's x minus 3 squared. It's a law as far as decomposition is concerned. Okay, and then after we got the denominators, we had to get common denominators to add that right-hand side together. So we went and got common denominators, made that happen. So that's what happened in each one of these. Common denominator, common denominator, common denominator. We multiplied a little. And then I added my numerators over this common denominator. So here's my numerator over a common denominator. And then I just did a little simplifying. We're good to go. Well, look at these two fractions. They're equal to each other. They have the same denominator. So if you can imagine, all we're going to do now is set numerator equal to numerator. Okay. So that's the piece that comes up next. We can now drop all that other stuff and just do numerator to numerator. So here's where you're at. You're at negative 2x squared minus 8x. I'm going to do a little more simplifying, plus 45. I'm going to distribute that a. It's equal to ax squared minus 6ax. So I'm going to have a phone charger, an iPhone charger with them that I might borrow. Yeah, mine's going to die here in a minute. That's all right. I might be able to make it. But thank you, though. Okay, so I just distributed the A. You're good with that one? Do you remember next step was, oh, gracias mucho. Gracias. Okay. Do you remember the next piece was just plugging in? Made me think of that. We're combining like terms. So I'm going to go find some like terms in there. I need to find x squareds. Gotcha. I need to find x's. Everything with an x. Ooh, there's 3 of them. 6ax. Negative 6x, negative 3bx, cx. Okay, how about all the constants? Just one of them. So keep an eye out for those like terms. Okay, and they come together. So we get all the x squareds get added up with a single x squared. So let's do them. A and a b. A plus b x squared. And then what else do we got? X's. So plus, let's get all our x's in one pool. We got negative 6a. Oh, that was times x. And a negative 3b. And a c. All with x. And then the 9a.
Is there a shorter way of doing this? I believe there. I did.
That'd take all the fun out. So that process, do you see by combining like terms, we just turned it into a quadratic that's in the same form as the left-hand side. Can you kind of see that? Got an x squared here, got a negative 8x, and I got a 45, a constant. This is where you line them up and say, all right, I need to have a plus b. Whatever a and b are, that a and b better add to negative 2. All right, whatever that's Nick said was 6a plus minus 3b plus c. Oh my word, that's horrible. Well, it's got to add to negative 8. And then 45. 9a better be 45. Okay, we can do that. Hey, does that give you any clue on what a might be by any chance? 5. We actually have a.
You lost me.
It just handed me a. So even sorting it into this order, what you're doing, just think of the goal of this is, I am trying to make the right-hand side in the same form as the left-hand side, so I can literally say, hey, whatever's in front of x squared, it's got to be negative 2. Whatever's in front of x needs to be negative 8. And whatever's in front of that constant's got to be 45. That's the system we're going to solve. A plus b has got to be negative 2. Negative 6a plus or minus 3b plus c, that's got to be negative 8. Hey, 9a, that's got to be 45. So I think we got something here. Do you think we can do some substitution? Are you okay with just a, b, and 5? Can you just roll with that one? A's 5.
Do you have to do substitution?
You don't have to. Do you want to pull out a matrix calculator and go, wham, here's my column A. I put all my coefficients into one big matrix and do RREF. Spits it out.
A plus B is equal to negative 2. So
Oh, yeah, we can just put it back in there. I got B. No, I have A. Take that back. Okay, so you plug it in. Should we do that in pink? What if I put the A in there? Can you give me B? Yes, you can. Negative 7. Good job. You want to put those two in for A in this one? So you go negative 7 right here. You want to put in B? Oh, that is B. Whoopsie. 5 and negative 7. Let me take that out, take that out, take that out. 5 and negative 7. Put them in there. What's that make? Negative 30 plus 21. And then you subtract it or add it to the other side. We got, is that 1? Dang. There you go. We just found them. A is 5. So back in the beginning, A is 5. B, negative 7. And C is 1. Now the directions back in the beginning, if you go look at it, were find the, it was the fractional decomposition of that expression. Well, guess what? All I have to do is circle and say, found it. I didn't see where it was before, but now I can see it. There it is.
What?
It says find the decomposition of that fraction.
It's right there.
I know, right there. That's what I said. Found it.
We did all that work for nothing?
No. It wasn't there
Oh, it
before.
wasn't there before. I was like, wait, what?
Tricked you. It wasn't sitting there. We just made it happen. Whew, was that something or what? I think you're feeling